Today, we're diving into a really interesting new AI model called Jamba. It's being called a hybrid, and the big claim is that it smashes through one of the biggest roadblocks in AI right now, something called the memory wall. So let's unpack what that actually means.
But before we get into all the nitty-gritty details, let's just start with the bottom line, the economic hook. What if you could process 3 times, not a little bit more, but 3 times more data on the graphics card you already have? Imagine feeding an AI an entire book or a massive code base all in one shot. That's the promise we're talking about today.
To really get why this is such a huge deal, we have to talk about the current king of AI, the Transformer architecture. It's incredibly powerful, no doubt, but it has a secret, very expensive problem, a problem that people are calling the memory wall.
And this slide just lays it out perfectly. On the left, you've got the Transformer. Its costs scale quadratically. Now, what does that mean in simple terms? It means if you double the amount of text you give it, the computing power you need doesn't just double, it quadruples. It gets out of control fast. What you want is on the right, linear scaling, much more predictable, much more sustainable.
And to put a real number on that problem, look at this. A model like Llama 2 needs 128 gigabytes of memory just for its KV cache. That's basically the model's short-term memory. 128 gigs. That's more memory than most high-end server GPUs even have. You literally hit a physical wall. So, researchers have been hunting for an alternative for years, and one of the most exciting contenders to come along is an architecture called Mamba. It's built on a different idea called state-space models, or SSMs for short.
So what is an SSM? Well, think of it like this. It reads through a document one piece at a time, and it keeps a kind of running summary of everything it's seen so far. The really critical part is that this whole process is super efficient. It scales linearly. You double the text, you double the work. Simple as that. No more runaway cost.
I love this analogy from the Hugging Face forums. It makes it so clear. An SSM is like speed reading a document while taking notes. It's fast, it's efficient. A transformer, on the other hand, is like stopping at every single word and comparing it to every other word in the entire document. You can see why one is so much more demanding than the other.
So this is the big question, right? If these SSMs are so great and solve this massive scaling problem, why isn't everything a Mamba model? Why are we even still talking about transformers? Well, as it turns out, Mamba has a catch. It has its own weakness.
And here it is. Mamba's Achilles heel is recall. Pure Mamba models, for all their efficiency, can sometimes struggle to find a specific needle in a giant haystack. They have a tougher time precisely recalling one little fact from way back on page 1 of a 1,000-page document. And that's where the Transformer, with its brute force method, really shines.
And this is where Jamba finally enters the picture. The team at AI21 Labs looked at this problem and asked a brilliant question. Instead of choosing between the efficient Mamba and the powerful Transformer, why not just use both? Jamba is their hybrid solution designed to get the best of both worlds.
And this is the core idea right here. Take a look at what they call a Jamba block. You see that pattern? It's 7 efficient Mamba layers doing most of the work, followed by just one powerful and expensive Transformer attention layer. It's a 7-to-1 ratio.
So the strategy is actually pretty simple and elegant. You let the fast, efficient Mamba layers do all the heavy lifting, processing the text sequentially. But then, every so often, you bring in a Transformer layer to look at the whole picture, to cross-reference everything and make sure those crucial details aren't lost. It's like having a team of sprinters and one long-distance strategist.
Okay, so that's the theory. It sounds great on paper, but does it actually work? Well, let's look at the numbers.
And the results are, frankly, they're stunning. Okay, remember that 128 gigabyte memory requirement for Llama 2? Even a more modern model like Mixtral needs 32 gigs. Now look at Jamba, 4. Just 4 gigabytes. That is an 8-fold reduction compared to Mixtral. It totally changes the kind of hardware you need. And it's not just about saving memory. It's also about pure speed. Throughput is just a measure of how many words per second a model can get through. On these really long documents, Jamba delivers 3 times the throughput of Mixtral. So it's not just fitting more data, it's chewing through that data way, way faster.
And this number really brings it all home. On a single standard 80-gigabyte GPU, Jamba can handle a context of 140,000 tokens. That's a huge amount of text, and it makes these long context applications economically viable to run yourself in a way that just wasn't practical before.
So this isn't just a cool science project or a technical curiosity. This has some really profound economic implications for the entire AI industry.
At the end of the day, it all boils down to a very simple equation.
When you make something this much more efficient, you're not just making it cheaper, you're making it more accessible to a whole lot more people, developers, and companies.
And that accessibility unlocks so many new possibilities. Suddenly, it's actually affordable to build applications that can analyze an entire legal contract or a company's whole code base in one shot. It means you can host these super powerful models on a fraction of the hardware, which slashes your costs. And big picture, this could really help democratize the next generation of AI. Which leaves us with a final, really interesting thought. For years, the big debate has been about what comes next. What's going to be the transformer killer? But maybe that was the wrong question all along. Jamba suggests that the future might not be about one pure architecture winning out over another, but about clever, powerful, and efficient hybrids like this